Good morning, class. We're going to be wrapping up our unit on the Renaissance today, and we're going to finalize things by finishing up with the scientific revolution. Now, we've taken a look at how art and architecture and education, everything has kind of morphed and changed, going from Italy into the north. And you look at all these different ideas and all these different monumental shifts. Well, to kind of cap things off here, the scientific revolution is going to be equally, if not even more, important for the history of mankind. So let's take a look at this and we'll get into it. And we'll wrap up Unit 1. You folks will have a review. We're going to have our first open note test next week after our short winter break. Okay? Alrighty, here we go. So let's take a look at the roots of modern science. Now, before the year 1500, most scholars, most educated people, decided that what was true or false was really based on Greek, Roman, or biblical texts. So that was their reference point. They would go back to those, and that was about it. Now, during the Middle Ages, most scholars believed that the Earth was an immovable object at the center of the universe. Okay? The moon, the sun, and the planets moved in a circular path around the Earth. This theory was called the geocentric theory. Again, that prefix geo, referencing the earth. Now, Christians were taught that God had placed the earth at the center of the universe. As scientists began to develop new theories, they launched a new change in Europe known as the scientific revolution. This way was based on careful observations and a willingness to question accepted beliefs. So all of a sudden people are saying, hey, maybe what we thought was true in the past really isn't true. And we want to test it, we want to prove it through science, and we want to make sure that we're 100% correct. Exploration led to a fresh sense of the world. Advancements in astronomy, mathematics, and science started to become more widespread. Now, as this is happening, though, you have to understand that the implication is that it could be dangerous to challenge the church. So, let's take a look at a revolutionary model of the universe. Remember, scholars and scientists at the time, for many, many years, looked at it as the geocentric theory. Well, all of a sudden, in the early 1500s, people started to question that geocentric theory. They felt that this theory was not practical and it was not accurate. In the early 1500s, Nicholas Copernicus theorized that the Earth, planets, and stars revolved around the sun. Whoa, this is a big change. This is known as the heliocentric theory. Again, helio in reference to the sun. So all of a sudden, it's not the Earth that's the center of the universe here. Maybe we're all moving around the sun. That's what Copernicus is bringing to the table. Now, Copernicus' theory still didn't explain why planets orbited the way that they did. To expand upon his work, Johannes Kepler declared that mathematical laws govern planetary motion. One of these laws proves that the planets moved with elliptical orbits and not circular. So again, a little bit more oval shaped as opposed to a pure circle. Kepler's laws show that Copernicus was right. Planets did revolve around the sun. This is huge, and this is a big, big change. Now, let's talk about Galileo's discoveries. So an Italian scientist named Galileo Galilei built on these theories. Galileo announced that Jupiter had 4 moons, and the sun actually had dark spots on it. He noted the Earth's moon had a rough surface as well. This shattered theories held by Aristotle that suggested the moon and stars were made of perfect substances. And now he's starting to realize, hey, they're a little bit imperfect. They're not perfect spheres. There's blemishes, there's spots, there's rough surfaces. So Galileo's findings frightened Catholic and Protestant leaders because it went against church authority. It went against everything the church stood for. If he exposed the church for being wrong, then others may start to question other teachings as well. So what the church is afraid of is this going to cause a domino effect? Are his teachings going to kind of create this momentum where everyone starts looking at the church and saying, no, we're going to start developing our own theories? In 1616, the Catholic Church warned Galileo not to defend the ideas of Copernicus. So what we see here, folks, is a struggle between the two parties. Okay, although Galileo remained publicly silent, he continued his studies. In 1632, he publishes concerning the two chief world systems. In it, Galileo clearly supported Copernicus and the heliocentric theory. The Pope angrily summoned Galileo to Rome to stand trial before the Inquisition. Under the threat of torture, he knelt before the cardinals and read aloud a signed confession. This confession signified that the ideas of Copernicus were false. And what he's basically, he's at a point here where he's facing excommunication and potentially death if he doesn't agree to this signed confession. With his career ruined, Galileo was subjected to house arrest until his death in 1642. His books and ideas would spread across Europe, for hundreds of years. It wasn't until 1992 that the Catholic Church formally acknowledged that Galileo was right. It took them that long to recognize that what he was saying about the stars and about the universe was true. And that, again, is really what we're looking at here with a huge rivalry between science and religion, and the two just not meshing and not getting along. So again, here is a famous painting which refers to the Pope and Galileo essentially having to go to his knees and declare that signed confession, essentially ending his career as he's going to go into house arrest. Now, the thinking of Copernicus, Kepler, and Galileo led to a new way of approaching science. This became known as the scientific method. You may have heard of it. It starts with a general question based on an observation. So we come up with a question. Next, a hypothesis, prediction, educated guess is formed. The hypothesis is tested in an experiment or on the basis of data. Scientists would then analyze and interpret that data, and a new conclusion, a new truth is produced. It is set in stone. Now, Francis Bacon and René Descartes urged scientists to shed medieval and ancient beliefs, get rid of all of these old school ways of thinking. Bacon came up with a concept known as empiricism, or the experimental method. And Descartes was known for creating the link between algebra and geometry. This is known as analytical geometry. So we have other scientists getting into the mix, getting involved. We have another one here that's going to be pretty important. So other scientific advancements to wrap things up today. Isaac Newton's laws of motion. His 3 laws on motion. These laws on gravity helped explain how the same physical laws work on Earth and in space. So number 1, law 1. Every object in a state of uniform motion will remain in that state of motion unless external forces act on it. So it's going to stay in motion until something hits it. Law 2, force equals mass times acceleration. So a moving mass and its acceleration rate. That's what we're looking at for force. And then law number 3, for every action, there is an equal and opposite action, or what we call reaction. So Isaac Newton, these 3 laws on motion and gravity, huge. Andreas Vesalius is going to publish The Structure of the Human Body. This book details human organs, bones, muscular tissue. Vesalius is going to dissect tons of human bodies for his research. So now, all of a sudden, again, scientists are starting to look at the body, how it functions, how it works, where the problems are at, how disease spreads. So this is really kind of one of your first anatomy books that sets the tone for looking at the science of the human being. Lastly, Robert Boyle is going to publish The Skeptical Chemist in 1661. This book asserts that the physical world is comprised of small primary particles that are joined together in different ways. He also established Boyle's law, which you may have heard of. This law explains how volume, temperature, and the pressure of gas affect each other. So again, some huge momentum created by these scientists, and they're going to have to endure the wrath of the church Again, some willing to sacrifice their careers like Galileo in order to push the message and say, listen, this is what's true. We've tested it. We've proven it. And that's what the big thing is with this unit. Okay? All right, folks, again, we're going to have a unit review. We'll have our tests next week. We're going to continue working on our projects. I hope you have a great weekend. Take care of yourselves, and have a good one.